Hi, everyone. Thank you for joining us today for this webinar. Jason Allen here, the Concrete Pipe Guy. I'm the Technical Resource Engineer for Oldcastle Infrastructure in the Mountain West, and I will be presenting today's webinar. The topic is box culvert installation. So let's jump right into that. Now, as we're talking about installation, there's three main takeaways that we're going to discuss in the webinar. And first is pre-installation, basically anything that we need to take into account before we start installing these box culverts. We're going to discuss the different types of joints that we provide at Oldcastle Infrastructure for box culverts. And then we're going to get into some of the best practices for installation. So let's jump right in. Now, as we start looking at that pre-installation part, let's go over a few of the specifications and things that you need to be aware of on the different types of specs that we have. There's different national specifications in ASTM. There's some more project-specific specs. There's a recommendation from our National American Concrete Pipe Association on how to install. And so I just want to go over a few of those in this webinar to kind of set the groundwork before we get too deep into this. So the first one would be the national specification, ASTM C1675. This is the box culvert specification that is nationally accepted. And the great thing about it is it's very comprehensive. It covers a lot of the box culvert installation information there. However, when we look at individual projects, we probably need a little bit more project specific detail. All right. Now, ACPA, as I mentioned, the American Concrete Pipe Association has a concrete pipe and box culvert installation guide. Now, this is a little bit more detailed and has a little bit more information, but because they're representing all of these different national companies and things that are part of the association, it still maybe doesn't quite fit every single thing that every different plant does and every different company does. And so it's maybe not as detailed as it could be. So then when we start getting into project-specific specifications, then we're able to see a lot more detail. And it's really up to the project engineer on what to include in these specifications and what to require in different projects. Okay. So when we start looking at ordering, receiving, and handling, this is a very important part that I think sometimes is overlooked. So let's jump right into it. When you get a box culvert and you receive it on site, you're going to get, you want to double check and make sure that you're getting the right piece, that it matches up with the project, that it's the size of box that you were expecting, that it's the number that matches up. Now, sometimes you may see a project map that lays out different sections. Not all of the sections in a box culvert are always the exact same. Like this drawing that I'm showing here, this CAD drawing here on the screen, you notice that there's different numbers for each box and there's different sections, and some of the sections have bevels and some don't, and some are straight away. Now, this isn't always the case, but you always want to check the shop drawings and check the submittal drawings to ensure that if there's different project or different numbers of boxes and different lay lengths and different angles and things that it needs to be installed at, you want to double check and make sure that the number on the box matches the number on the drawing. So for instance, as they come in on a truck, you could see on this truck, it has the number 7 painted on the side there. So that would correspond with the number 7 box on the plans. Now, sometimes there might be multiple number 7s. So in this section, you set all the 7s next to each other, but you just want to check those plans and make sure that what you're receiving on the truck matches up with those plans. The other thing that we recommend is that you have a good open area to stage these if possible. So if you're going to be unloading them from the truck, we want to have a good flat area to stage these, to remove them from the truck. Now, sometimes you'll install them directly off the truck. So if there's enough room that a truck comes up, we take them from the trailer and put them right into the trench. That can happen sometimes, but if not, we want to make sure that we've got a good area to stage these in, and we don't want to set them directly on the ground. So if you see the box on the left-hand side of the screen there, you can see it's actually slightly elevated. There's a little bit of dunnage underneath that box culvert, so we don't want it sitting right on the ground, so we're not creating unnecessary point loads. So we want to put some 4x4s or some type of dunnage underneath that, so that it can rest on that and it's not being loaded, or it doesn't have a point load from like a rock or something under it that's going to create unnecessary loading on that. So most of our projects, when you get some engineered drawings for these box culverts from our structural engineer, our in-house structural engineer, when you receive those, they're going to have some type of lifting diagram. So this one here, this one says, if you notice, 8-foot chain required for safe lifting. Now, this is for this specific project. It doesn't mean that every project is that an 8-foot chain is going to be acceptable. On this one as well, it's got 4 lifting points you can see, and it comes up to a single point. Now, sometimes you might have on larger box culverts, on larger bridge sections, you might have maybe 8 points, 8 lifting points, and you might need, there might be a little bit more complex lifting plan. But when we look at these lifting diagrams, you want to make sure that you read and check and see what the requirement is to make sure that we're lifting these things safely. Now, one rule of thumb, if you're ever in doubt, here's a good little rule of thumb. We call it the 60-degree angle rule. Now, what that means is that the lifting cable itself should create a minimum of a 60-degree angle with the top of the box. Now, that might be hard to visualize. You might go, now, wait a second, how would I have... do I have to get out there with a protractor and measure it and determine what that 60-degree angle is? Well, there's a pretty easy way to determine that. And what we recommend is that the distance between the 2 kitty corner boxes, where the 2 diagonal lifting points, the 2 furthest lifting points, so this distance here, okay, between those 2 diagonal lifters should be at least equal to this distance here. Okay, so that would be the 2 furthest points of the lifters should be at least the height of the lifting chain. So it can be higher if you want, that doesn't matter, but we just don't want it to be any less than that. Okay, so I want you to take a look at this next picture and see if it meets the 60-degree rule. Okay, so if you look at this one here, right, you've got the lifters there. You could see that, does that create a 60-degree angle? No, it does not. Right? If you go back to it, it maybe is probably closer to, God, that to me, that almost looks like a 30-degree angle or less. So that, in my mind, it looks like we're probably half the distance we should be. Okay, we should have a lot more give on that chain. Now, this is common in projects when we're trying to, if we don't want to rent a crane or we don't have a crane available and we're trying to lift these using, in this case, we've got this track hoe that we're trying to lift this up with. Maybe you don't have the arm length that you need to lift it, and so they're trying to shorten those up. But we really want to make sure that we're looking at these lifting diagrams, because if we have this situation here, right, which we say is not acceptable, it can create loads in the middle of the box. And what happens is, as that outside force is pulling, we create this tremendous moment on the inside of the box at about the middle of it. So in this picture, this is exactly what happened on a project like that. They didn't use long enough lifting chains or lifting cables, and it created this tremendous bending moment and a lot of tension in the box, at the center of the box on the inside there. You can actually see the exposed reinforcing steel on the bottom where the concrete has sloughed off, and it's caused a great problem. So this is a major issue if we're not lifting these things correctly. Here's another picture of some concrete that fell off of that same box. It just sloughed right off and busted right out of there because we didn't have long enough lifters. Now, here's a picture of proper lifting length. You can see the diagonal distance between those 2 furthest lifters is definitely less than the lifting cable length. So that's creating greater than a 60-degree angle. So we're good there. That's a good one. That one's actually probably pretty close to 60 degrees. This is another one that you could see it's much greater than 60 degrees. And so the lifting cables are much longer than that diagonal distance. So these are good. Those are a couple of good examples of good lifting there. Okay. So let's get into site preparation. So when we start looking at site preparation, the first thing that you want to do is, as these boxes come in on the truck and they come to our site, we want to make sure that we are inspecting each box culvert section prior to installing them. Now, and when I say prior to installation, I mean we should be inspecting them when they come off the truck. If we're staging them anywhere, we need to check them before, as we take them from staging, before we put them in the trench. I've seen cases where sometimes product will be staged somewhere, and maybe unbeknownst to the rest of the crew, someone backed into a pipe or a culvert or a box culvert or something and damages it, and we don't really notice it or know about it. So then we lift it up, we go to put it in the trench, and maybe it gets in there and we don't notice. That causes a lot of problems down the road. So you always want to inspect these right before they go into the trench and right before we install them. If there are any problems with a box, if a box has become damaged, please let us know as soon as possible so that we can come out and check and see if there's a way that we can repair them. Some of these box culverts, if there's any issues with them, we might be able to repair them. Or if we need to pour a new one, then we need to know as soon as possible so that we're not holding up a project because something was damaged out on the construction site. Okay, another thing that we want to make sure that we have with the site preparation is we want to make sure that we have the appropriate trench width. And when I say appropriate trench width, we want to make sure that we have enough to get the box into the trench. Obviously, we want to get it in there, but we need enough that we can do the necessary compaction that the project requires as we come in on the sides of that, right? We want it to be safe so that we can get good compaction in there. And if the project has compaction requirements, we need to make sure that our trench is wide enough to either lay those slopes back or put some type of shoring up so that we can get in there and compact on the sides of these box culverts so that we don't get any unnecessary settling on the roadway above it. Okay. Another thing that we always want to make sure of is that we are dewatering the trench. We don't want to be installing these in a trench that has water in the bottom of it. A lot of times when we're doing box culverts, we're coming in and replacing an existing canal or an existing, whether that's an existing concrete bottom canal or a earth line channel, and a lot of times these canals can have water in the bottom of them. And if that's the case, we want to make sure that we have that we've taken into account the dewatering that we have to do to get that bottom dry so that we can get a good foundation there, a good leveling course, and get these things done correctly. Another thing that we want to make sure that we're doing is that we're planning out how we're going to install these. Okay, we want to start downstream and work upstream. So as such, we're going to place the groove or the bell of the box culvert. We're going to place that upstream so that the spigot end or the tongue can come into that bell or groove. Okay, so we always place the groove or the bell upstream, and then we use gravity to bring the tongue or spigot part of it into that. And then we also want to keep in mind installing a transverse trench. Now, a transverse trench is basically just a small little trench. After we install one box, we want to come in and make sure there's a little bit of a space, a little trench along the face of that box culvert we just installed. And it doesn't have to be deep, just an inch or so. And the reason is, as we're installing that upstream box, as it comes in, if it happens, even though we're suspending that load on the lifters and we're keeping it up elevated as we home it in, every now and then it can still grab a little bit of material, some of our leveling course or some of the material from our trench, and it can pull it into the joint. If we have a transverse trench that's just maybe the width of a shovel, as we go through and dig that little trench, any material that the bottom of the box culvert grabs, it's going to pull it into that transverse trench, and it's going to make sure that it doesn't get into the joint, and so it won't cause any problems as we start homing these things in there. Okay, so this is a picture of a trench. As you can see, there's some issues with this trench. The walls on the side maybe aren't shored up very well. We need to do a little bit of work there. You've got some vegetation on the right-hand side. And one thing that I notice is it's very, very muddy. Right. So we've got to do some level of trench preparation on this to get that water out, to dry it out so that we can get a good solid foundation for these box culverts. The last thing we want is for these box culverts to settle over time. So we need to make sure that we have a good, strong foundation. And the only way we can do that is to make sure that we've got these trenches dewatered and that we're putting in the proper foundation that it's called for in the project specifications. So you can also notice there's that roll of geotextile fabric, some stabilization fabric there that we're going to put down to make sure that this trench bottom is stabilized. So this is as they got going and dewatered that trench and got that stabilization grid, that geotextile grid there they've got it down, and then they're bringing in that material to compact and roll over it so that we have a really good trench bottom there. So they've done a really good job of taking that trench and dewatering it and getting a geogrid down, and then backfilling material and compacting it over it. And this is basically what it looked like afterwards. Now, one thing I want to point out is notice they're cleaning the joints, right? They want to make sure those joints are cleaned. And as they lift that box, you want to make sure that any dirt or anything, any soil that was collected as it was staged, anything that got on the bottom of there, we clear that off. So you notice he took the shovel and cleaned that off, because any of that material that gets in that joint, that could cause problems later down the road. And then, you want to make sure that everybody's clear, that it's safe areas as we load and we move these around. This is another one where, as you look at it, it's pretty questionable on whether they have enough lifting in there, and that those lifters could have been a little bit longer. I would recommend that they do those a little bit longer, but they've got the trench ready. They've cleared everything off the bottom, and they're ready to put it into the trench there. All right. So let's talk a little bit about bedding and backfill. This is a very important thing. We already talked about dewatering and getting the trench ready for that. But one thing that I think a lot of people forget about is a leveling course. That's a really important part there. We want to make sure that we have a good foundation, but our recommendation, our manufacturer's recommendation, and when we talk about installation guidelines with ACPA's installation guidelines, the ASTM specs, and then any project-specific specs that we write or help engineers write, we always recommend some type of fine granular material of leveling course, typically about 2 inches thick. Okay, so that would be sand or pea gravel, something that's a small material. So when we look at bedding, right, we want to make sure that our bedding or our foundation there is 6 inches minimum or per project requirement. So one project may have something a little bit different, and recommend either more or less than that, but you want to look for the project requirements. Our recommendation is always 6 inches minimum. And the base material should be a medium to fine grade. This is for that foundation, right? So you want it to be, you don't want to have big rocks in there, big material. So it's, you're going to want a medium to fine grade material, like a 3/4 inch minus. Okay. Now, we also want a 2-inch leveling course to be used, as I mentioned there. And the final grade of that leveling course should be achieved by screeding it. Okay, because we cannot force these to grade. You can't put the bucket on the top of this box culvert and push it and smash it down onto grade. You've got to make sure that it's graded. We recommend that you go out there and create like a 2x2 grid. And after you get your leveling course in and you've screeded it and it's all smooth and leveled out, take a level and go out there with a rod and a level and do like a 2x2 grid, and make sure that 2x2 grid is level. That's kind of the best way that we recommend to do it. It takes some extra time and some extra care to make sure that it's done correctly, but if it's done correctly, this is a really, really big deal on how we can get this thing installed quickly on the back end. Okay. So when we start looking at this leveling course a little bit more, the maximum depth of that leveling course should be 2 inches, and the maximum particle size should be 3/8 inch. We would recommend something that flows a little bit better, like a sand would be good. If in the absence of a sand, like a 3/8 inch pea gravel would be good. We recommend that that you don't use like an angular or crushed gravel, but it would be more of like a round gravel, so that it can, you can screed it a little bit easier and get it nice and level. The more angular rock you have and the bigger material that you have, the more likely you are to create a point load on that box culvert, which is going to cause major issues with the loading as you start backfilling and putting material or traffic loads or anything on top of it. So we don't want to see that happen. Now, when we backfill, one thing we recommend is that we do it in uniform lifts. So instead of backfilling on one side of the box culvert, you want to make sure that you're backfilling in uniform lifts. So if you do a foot on this side, on the left-hand side, then you're going to come with a foot of material on the right-hand side, and then a foot on the left side, and then a foot on the right side, and then a foot. And you just do it in uniform lifts, because even though these boxes are typically very heavy, coming in and compacting on one side and going all the way from the floor of the box culvert in the trench up to the top it can actually shift and move the alignment. And we don't want to disturb that at all. So you want to make sure that you're backfilling in uniform lifts to preserve that alignment of the box culvert. All right. Now, this is a video of a project that we did on I-15. You can see the traffic going. And this is them bringing the material down in a bucket that they were going to use. This is the leveling course material that they used. Okay. It was like a sandy round pea gravel. And here's another video of them. See, they use this bucket, this basically the same thing, like they're installing a sidewalk almost. It looks kind of like they're installing a sidewalk. They've got rakes. They're using it to spread this material out. In this case, they actually use 2x4s to form it so that they know how deep they want this thing to go, and they mark it on the 2x4s where they're at, and then they come in here and move it around and screed it. And they end up taking a board now and screeding it so that it's perfectly level. And they come in and get this thing put in there, and it ends up working pretty awesome. Here's a picture of it as they're screeding that to get that nice leveling course. You could see that's a very sandy material that they're using, and they're moving it to screed it to get it perfectly level. Now, one thing I do want to point out is notice, as I mentioned, on the face of that box culvert, and then right next to that 2x4, they have that transverse trench that we talked about, right? They're leaving just a little bit of a gap. It's only, in this case, these boxes were 24 by 6.5, so a big box culvert, but they left about 8 inches or so of just a transverse trench. So as they brought these boxes in, if it were to grab any of that leveling course material, and as they're pulling it and homing it in, instead of getting into the joint, it's just going to fall into that transverse trench and not affect the joint face at all. So speaking of joints, let's jump right into the different types of joints that we have on these box culverts. All right. Now, there's the joints that we use are a tongue and groove joint. Okay. And so instead of like a bell and spigot that you'd see on a reinforced concrete pipe where the bell kind of extends out, these tongue and groove joints are perfectly flat along the top, sides, and bottom of that, of the box culvert. Okay. Now, there's 2 different types of sealants that are typically used. The first is a bitumen-based sealant material, or mastic, right? A bituminous mastic is very common. And this is regulated by the national spec ASTM C990, okay? The other type that we make in our Utah plant out of Ogden, Utah, is rubber gasketed joints. So we have the ability now to make rubber gasketed joints, and those are regulated by ASTM C1677. That's the national joint that addresses rubber gasket joints. All right. So first, we're going to talk about that bituminous mastic, that type of joint sealant. And so when we install box culverts with a mastic sealant, okay, we want to place the mastic on the bottom groove of the last box that was placed. Okay. And then what we do is we place the balance of the mastic on the top of the tongue and the sides of the tongue of that next box as it comes in. We want to ensure that in order to get this thing to seal, we want to make sure that there are no voids and there's a slight overlap there. Okay, now there's on that overlap, we want to have a 1/2 inch minimum overlap, but you don't want any more than 1 inch overlap, because too much overlap can cause some major issues. Now, I want to point out that this type of joint sealant, this mastic joint sealant, this is what we call a soil or silt tight joint. This is not going to get you a watertight joint. It's not going to be water or airtight. People ask us all the time, are they airtight or are they watertight? A mastic joint is not going to get you there. You have to do some other type of joint treatment in order to get this joint watertight. So this is a very common, a common installation practice. But if you want true water tightness, you're going to have to do some level of sealant in addition to the mastic. So keep that in mind, that mastic joints are silt or soil tight joints, not watertight. Okay. So as I mentioned, you want a 1/2 inch to a 3 inch joint gap there so that the mastic, as it comes in and is compressed, right? You've got that mastic material in there within that joint, and that's what creates that soil or silt tight joint. So here's a picture. As I mentioned before, this is the box that's already been installed. You could see the mastic that they put it along the bottom of that, and just a hair, just about, coming up to just coming up maybe 6 to 12 inches on the box there. It just comes up the side there on the box that's already been placed. Now, as you do this, as you install this mastic in there, okay, you want to make sure it's very clean. Any dirt or silt on there might affect the ability for it to stick on that. This is very sticky material, but it's not so sticky that if it's there's dirt or soil on there, it's not going to stick as well and it's not going to do its job. Now, in another project that we had, it I want to point out that this mastic also, it needs to be dry. Okay, the surface needs to be dry. If it's wet, it won't stick. So notice on this one, they're using basically a burner or a flamethrower to dry the sides of the box culvert so that it'll stick to that. Because in this case, it rained the night before and it got the box culvert wet. So they were drying it out so that it will stick. So here's a video of them putting that on, just hitting it with a mallet so that it'll stick on the bottom of that box culvert. And then, as I mentioned before, we put it on the bottom of the box that we already installed. And then the next box, we put the mastic on the tongue. So we were on the groove of the previous one, and then the one that's coming in, we put it on the tongue on the top and the sides so that we have a little bit of overlap. In this video, you can see that they had that mastic coming up the side, and then as this one comes in, you could see that it matches up almost perfectly. It marries just really nicely in there as they start homing it and bringing it in. So that works out really well. So now let's transition and move over to rubber gasket joints. Now, the benefit of the rubber gasket joints is that these actually do provide a watertight joint. So in the mastic joints, remember, those are silt or soil tight joints. Rubber gasket joints, these will provide a watertight joint without having to do any other joint treatment, okay? What the gaskets that we use on these are very similar to the gaskets that we use that are commonly used in reinforced concrete pipe, and these are what we call pre-lubricated gaskets. So I cannot stress this enough. You do not add lubricant to these gaskets. They're already lubricated, and I'll show you in a minute a little graphic of what that looks like and how the lubrication works, and as we home it and as we bring it in, how it works, okay? Now, these rubber gaskets are typically installed at the plant. We'll actually glue them and affix them to the box culvert unless they're traveling really far distances. But if they're just going a relatively close distance, we'll install those on the plant or at the plant so that when you receive those at the job site, you just have to lift them up and install them and put them into just pull them into place and home them there. If we don't install them at the plant and we're traveling long distances and we give those to you, we'll come out and show you how to install those, the first couple ones, so that you can get it right, and then we'll make sure that we're good to go with that. I did mention that they are a watertight joint, and so that's the main benefit of using these rubber gasket joints, is that they're watertight and they're almost the same cost. They're very similar in cost to the mastic joints without doing any watertight treatment on those mastic joints. So this is a really great option if it's available in your area, which if you're in the Utah and Idaho area, they are available for that. Okay, this is a picture that shows the joint. This is a box that is being staged. This has not been put into the trench yet. So you can see they're staged. The gasket is already installed at the plant. It's ready to go in. Okay, so the picture on the left here shows the gasket that's in place that we put on. This is in our plant. We've already put it in there. And then the picture on the right, if you notice, as they pull that back, the gasket itself is glued or attached to the box culvert, to the tongue of the box culvert. And then notice the glove, they're kind of pulling that back. Okay, that thing back. What that is that is what we call the rolling tube of the gasket. So here's a little diagram that shows how these gaskets work. If you look on the big area there with the red teeth in there, you notice there's these teeth, and it's got the lubricant inside that tube. That's the rolling tube. And what happens is, as you home these boxes in together, that rolling tube just rolls over the top of it. And if you notice in there where you have the nose of the gasket and the what they call the deformation section and the lamels, that is the actual gasket. That is the meat of the gasket. So look on the right-hand picture there, that thick part with the two holes in it, that is where the seal is happening. That is where we're sealing it. So as it homes in, that rolling tube will actually roll over the top of the gasket, and it allows it to just roll, and then those teeth inside it will hold it into place once it gets homed, and that lamel area will compress, and that's what's creating that joint. So that creates that seal, that watertight seal around that joint there, is that meat of the gasket there where those two lamel holes are. So that's basically how these pre-lubricated gaskets work, because the lubrication is inside that rolling tube, and as that rolling tube rolls over the gasket and goes into the annular space, it creates the seal, and you don't have to do anything. You don't have to add any lubrication. You don't have to do anything special with it. So it's a really, really good option. All right, so let's talk about what we do when we home the joint and we bring that box in. Okay, so what we provide in our boxes is we will cast pulling inserts into the box itself so that you can use some come-alongs to pull those together. We have two in every box, one on each side, on the inside of the box, typically. We've There's been cases where we've done them on the outside, but they don't work as well. So you want them on the inside of the box. We cast those in. At the end, you can either leave them as is. Some people will actually kind of fill them in with some type of sealant. It's not necessary, but they don't have any real bearing on the hydraulics of the box culvert. But that is an option. If you want to seal them in, you can do that as well. But you'd put come-along devices in there. You'd connect them with a chain and a come-along, and then you would use that to pull these things together. What we recommend is that you get the first few boxes installed. So you got to be very careful so they don't, as you're pulling them in, you're not pulling that, because these are pretty heavy. As you start homing it, you don't want to pull one box that's already been installed. So you want to go back, and once you get 3 boxes installed, you'll go back every time and go at least 3 boxes where you'll connect the come-along, the pulling insert 3 boxes back, and then you'll connect it to the new box that you're bringing in and use those come-alongs to crank those in so that the box can come in and be homed. When we're homing them, the recommendation is that you keep the weight on the lifting device. So whether it's a crane or a backhoe or whatever, you want to make sure that the weight of the box is being lifted. You don't want to set it on the ground and then home it. It's just too much pressure with the friction on the bottom of the box. And we also can grab more material there. So we always recommend that we keep it elevated and keep the weight on the lifting device itself. This is a picture of a lifting device of a pulling insert that is inside the wall of the box culvert. So this is what you would connect the come-along to. This is how it connects and what it looks like. And then you've just got that crank that you're going to pump to get them in. Here's a great video showing a contractor that as they're doing this, the great part about this is sometimes you get a little bit more on one side, so you have to make an adjustment, and you crank on one side, and then you crank on the other, so that if it's off center at all, this is a great way to get it back on center. It's a really cool system here. So here's inside the box. You can see how they're doing it. They're connecting it in and pulling that in together so that they can get it homed in just right. So pretty cool video there showing how that works. And then that's on the inside of the box. Notice he's directing, like, okay, lower it down a little bit. Now we've got to bring it this way and home it in. So that's good. And this is what it looks like on the outside as they start pulling that in and homing it. It starts coming in and homing together so that we've got, get that joint gap down to the 1/2 inch to 1/4 of an inch joint gap. And in this case, it's that mastic that gets sealed in there to make sure that we've got that soil tight joint there. So that's what it looks like there. Now, in some cases, you're going to need to do some type of closure pour or connect to maybe a cast in place section. So if you've got an existing section or you need to connect to a cast in place section, there's a couple of things that we recommend. Some type of reinforcing is going to be necessary to to seal it. Whether you, we would recommend basically 12 inches minimum coming out of our precast box. That can be done by, sometimes we'll actually cast it sticking out. Other times you could drill and dowel epoxy into the existing box culvert, and then you can use that to tie into it. But we recommend that you square off the concrete face if you're going to do any of that drilling, and then putting dowels and epoxy in there to hold it into place so that you can cast that together to hold them together. So those are pretty project specific, but those are the recommendations of what you should do if you're going to do that. So. All right, so just a quick review of what we talked about today. Obviously, we discussed the pre-installation, the things that you need to make sure are prepared before we get the boxes into the trench. Make sure that trench is ready, make sure that we've got the right sections, that it's the right project, that we've got a good place to stage it, that the trench is wide enough that we've dewatered it, and that we've got the bedding and leveling course ready to go. We talked about the two different types of joints, our soil tight and silt tight joint that's using the bituminous mastic. And then we also talked about the watertight joint that we provide out of our Ogden, Utah plant, which is the rubber gasket joint, which is a great option if you need a watertight joint. And then the third thing we talked about is the actual installation, how to home these boxes using the pulling inserts and come-alongs. And so it's a great option there. So those are our three takeaways and the three things we discussed today. So I do want to thank everybody for taking the time to listen to this training and this webinar about box culvert installation. For more information about this topic or any Oldcastle products discussed in this presentation, please feel free to email me at jason.allen@oldcastle.com or visit oldcastleinfrastructure.com.